Hello, and welcome to our first linear algebra video. For this first one, we're going to talk about the basic notation and basic terminology that we're going to be using throughout the course. So, first of all, you're used to the Cartesian plane with points in the Cartesian plane that usually look something like x, y. And you have equations with those variables, and you can graph them and all that stuff. You might have done if you've done multivariable calculus or maybe in some other classes, you talked about three-dimensional space where you can describe a point in three-dimensional space as a set of three coordinates x, y, and z. But a lot of the time, and a lot of the time in this class, you need to describe a point that is a collection of more than just three numbers, and that could represent a lot of things. For example, if you have 100 different variables, it probably doesn't really represent 100 dimensional space, but it could represent all kinds of other things. So a lot of the time, it's going to be handy for us to write it using the notation x1, x2, x3, and so on until you get to x99 and x100. And we're going to use this notation because we don't have 100 different letters in the alphabet that we could use, and it would get confusing if we did. So likewise with x, y, and z, you could also just write that if you want, x1, x2, x3, and it means the same thing. We're just using different, you're just calling them all x instead of calling the other two variables y and z. So using this kind of notation, we can define a linear equation, which is any equation in n variables which can be written like so, where the variables x1 through xn are all just multiplied by the constants a1 through an, but you're not multiplying any of the variables with each other, you're not raising them to any powers, you're just writing it as multiplication by constants and then adding them up to get a result. Quick example of a linear equation would be something like 3x minus pi times y equals the square root of 17. That is linear. A nonlinear equation might include something like 3x squared plus the cosine of y equals 2. Squaring things, cosines are not allowed in linear equations. And hopefully you remember that the reason they're called linear is that if you graph an equation like this, the graph turns out to be a straight line of some kind or another. And the line is linear. So also, a system of linear equations is a collection of linear equations with the same variables. And it turns out we can also think of one linear equation as just a system of one linear equation, and that works out okay. Most of the time, though, we're going to think of things as a collection of two or more equations, like you might have 3x minus 2y equals 6, and 7x plus y equals 2. And that is a system of two equations with the two variables x and y. Now, let's try to be precise about what we mean when we say let's solve a system of equations like this. First of all, let's define a single solution to be a list of values x1, x2 through xn that makes each of the equations true. So here you'd have to find an x and a y that makes the first equation true, and the same numbers when plugged in for x and y in the second equation needs to make that one true as well. So let's just do a super quick example here to check to see if 0, 10 is a solution of this system, and also check to see if 2, 4 is a solution of this system. And with examples, especially quick, easy examples like this, I recommend pausing it to try it yourself. You'll get a lot more out of the videos in general if you are not just passively watching, but if you're pausing it to do as much of the math on your own as you can as you watch as well. So, and then you can always fast forward again to the end, so you don't have to sit through the boring explanation once you get your answer. So anyways, with this one, let's plug in 0, 10 first to check that. So we're going to plug in x equals 0 and y equals 10. So 3 times 0 plus 10 equals 10. That sounds good. But then if we do 17 times 0 minus 3 times 10, is that equal to 22? That is not. That gives you negative 30 equals 22. So that is not that means 0, 10 is a solution of one of the equations, but it's not a solution of the system. And then if we try 2, 4 here, we plug that and let's see what happens. We're going to get 3 times 2 plus 4. We want to know, is that equal to 10? That looks good because that gives you 6 plus 4 is 10. And then if we do 17 times 2 minus 3 times 4, that's going to be 34 minus 12, which is equal to 22. So that sounds good. Sounds like 2, 4 is a solution of the system. So finding a solution like this is what it means to solve an equation, solve a system of equations. So if you're given the system, going through whatever steps you have to do to get there, to get to a point like 2, 4 means solving an equation. They're solving the system of equations. But you don't just want to find one solution, you want to find the whole solution set. And the solution set is the set of all solutions of a system. And when we say solve a system of equations, that's what we mean, find the whole solution set. And we're going to do a few examples of that in the next video. So I'll see you there. Or maybe you'll see me, but I won't see you. I guess you won't even really see me. You will hear me in the next video.